Hello, welcome back. Gonna have a little tool review, and is this a good tool to review? We'll find out. It's, as you can see, it's a soldering iron. Antex, a UK company, they've been making soldering irons since I can remember. Certainly when I was in my teens, I had a fairly simple little 18-watt Antex soldering iron, which lasted me for years, and I think I only kind of bought this out of kind of curiosity, really. I mean, this is the idea with this is it's a TCS 50 watts, so it's temperature controlled soldering iron, I guess. I don't know, but it's very similar to the sort of things you get where you've got a soldering station with the temperature control there, and but this is kind of all built into the unit itself. The problem, well, one of the slight problems with that is it does make it a bit bulky and not particularly, it's not like horrendous, but it's not particularly comfortable to use, no matter how they've tried to design this in a way that I've never really got on with it. But that, I mean, that's not really a deal breaker. It's kind of, this is by way of a long-term review and a bit of an autopsy, because the thing has died now. The first problem that I had with it, which isn't really, I wouldn't kind of call it a problem as such, is inside the cable there was obviously a break that developed right about here, because I was using it one day and I found out that it kept turning off and you had to kind of hold it like this, and in the end you had to just tape it in that position to finish what you're doing that day and order up a new length of lead. Of course, I suppose I could have just cut it down a bit, but I think the original lead that came with this was only just over a metre long anyway, so it was kind of like borderline too short. So anyway, I got a new lead. What I didn't ever do was replace a plug. So this is the original plug, and presumably came with it from, well, it did come with it from common factory, because I've never changed it, and it describes itself as a BS 546 to UK standards. That's not a BS 546 plug. It is actually a BS 1363. So quite what that sticker is doing on there, I don't know. BS 546 was an old standard of plugs we had in the UK with round pins, but probably doesn't bode well. All Antex's stuff, as far as I can remember, used to be made in the UK. In fact, I got, as a replacement, which may be temporary or not, I got this, and that's still made in England. This one doesn't say where it's made, but I think we can all guess. Right, so quite apart from the lead needing to be replaced, which is fine, the next thing that started giving me trouble was the actual bit itself started kind of sliding off, and that's an interesting one, because they used to, all Antex's bits used to have like this is a much smaller one, it's a little 12-watt iron, which is great for doing really tiny surface mount devices and stuff. But anyway, the tips, they kind of have a slot in them, and then this sprung part around which holds them on. They've changed the design, and it seems to have been across the board now, whereby they have it's in there as a funny little piece of spring steel in a kind of hexagonal shape. I think they tout it as having a better thermal conductivity and stuff. I don't know, I just found that after a while it worked so loose to the point where it was falling off, so what I had to do was kind of wedge a piece of copper wire in there. I can probably, this thing's already dead anyway now, for reasons that we'll see in a minute. But this, yeah, this is the really thin kind of bit that they call a shim or something like that, and as it comes, that just sits inside the bit. And it was kind of like, when it was new it wasn't so bad, but then after a while it got to this sort of stage, which is pretty pointless. So what actually happened to this, which is left it on the autopsy bench here? I cardinal sin, I left it plugged in and switched on overnight, only to see it the next day no longer on, or at least the display wasn't on, and I thought it might have had a timeout or something on it, so I obviously turned it off, left it for a while, turned it back on, still didn't work, so kind of decided to take it apart just to see what's broken and if it's even fixable. So anyway, if we just get rid of that for a minute, I'll show you how to dismantle it. It's not particularly difficult apart from one thing. All you need is like a #1 Phillips driver, and preferably do use a Phillips, not a posi drive. He says as he searches aimlessly for, there we go. So yeah, this cover, as you're taking a screw off, it just kind of again unclips somehow, and it does because I've had it apart before. So yeah, there. Next thing, the strain relief, just you twist it through 45 degrees, and then, well, just so, I don't know if you can see that, it's got little pores that sort of line up with cutouts, and you can take it, draw that back out there, and then there's a cable clamp, and this is something I've had to do before when I replaced the cable. Okay, so you kind of get to this stage where you can't get any further. Obviously these are the temperature up and down buttons on the thing, and if we try and lift the board up, it won't come. And it's not that it's kind of clipped in or anything like that. What is actually going on, and what you have to do, which is the really annoying bit and just shows that it's never really meant to be repaired, is you need to get something like a small screwdriver. These are glued in place, and pop the buttons off. Now you're at the mercy of whoever glued them on in the first place and how much glue they used as to whether or not you can get them off in one piece. Once you've got those out of the way, the board, you can kind of get it to it enough, at least to replace the lead. As I say, this thing wasn't, it's given up the ghost completely. And having a look over, the thing that I noticed in the end, there's a little surface mount resistor here labelled up R2, and you can see that it's burned out, left a bit of smoke on the backlight for the display, and a little witness mark there on the case itself. But because it's actually toasted, I can't even read the value off of it, and I can't find a reference as to what it should be, so I might just for laughs have a better look at the circuit and try and take a guess and see if I can replace it with something and just get it to fire up, see if it does fire up or blow up. Doesn't matter, I mean, I've got nothing to lose now. But yeah, I mean, I suppose at a pinch you could replace this element bit. I mean, that's something that typically you probably need to replace at some point anyway. It's a little bit complicated. Again, the annoyance is just the way those buttons are glued on, and you have to kind of take them off, and often they kind of break a bit or take a bit of the plastic off the back of the button, and I have to kind of stick the back on. I just think that there could have been a bit more thought put into that, but anyway, I guess they weren't really intending people to ever bother fixing it, which is a shame, because the old ones, it's just a very simple thing. I say the old one, this is a new one, but a new one of the old style, fairly inexpensive, and you can take that apart quite easily. Just take that little grub screw out there, take that screw out there, and the whole thing just the element comes out, and it's just simple. You just mains lead, just solder it on, which is why you always need 2 soldering irons in life, because if your soldering iron dies, you can't fix it without another soldering iron. Before I waffle on any further or try and take this apart any further, as this is a tour review, I better give you my long-term opinion. I wouldn't bother buying one of these again. and the reason for that is manifold. The problems I've already had with it. Also, when you get something like this, and it's 50 watts, and it goes up to you can turn it all the way up to 450 Celsius. It still struggled on even kind of, we're not talking about massive solder joints either. You know, if you had, say, a cable that sort of thick going into a PCB, so I don't know what that is in there. Certainly UK size would be sort of, maybe it's 2.5 mil. It would struggle, and it's probably mainly down to the bit that comes with it hasn't got a great deal of mass, so you can probably get a replacement bit. And if you are going to go for it, I definitely recommend that, because I used to struggle with even, well, not massive solder joints on it. It wouldn't have enough heat energy in the tip to melt it, even though it's turned all the way up. And I ended up having to use this thing, which is not really designed for electronics and is a bit unwieldy, but it is hefty. It's got a lot of weight to it, and it's 80 watts, and it kind of that works. But if you want something like this, I think you want it to be able to at least do a fair range of work with it, and I just found that it couldn't handle the bigger jobs. So that, combined with questionable build quality and the fact that I've probably not used it for more than 50 hours continually before it died completely, I just don't think I'd bother. I think I'd go for something like, get one of these proper, if you want something, get a proper soldering station, get I think the Heiko 888. I never used it, but that seems to be pretty well reviewed, so I would go for that instead. But anyway, yeah, so not their best work, I don't think. As an aside, I've only had this one for a couple of weeks and used it a couple of times. It's got a meteor bit on there, and it seems to cope better with soldering decent joints. It might be a bit much for really small scale stuff though. Right, well, if you want to hang around, I'll try and get a bit further into this thing. These two are the temperature sensing connections for the element. Yeah, I mean, interestingly, the element is something that you may well end up having to replace on this, and it's certainly not unreasonable to be able to expect to replace an element. So there's two mains connection. That grey wire is the ground. Obviously, it's a mains powered soldering iron, so that's, if you get the element breakdown, you're going to want to make sure that this is grounded, because in the UK at least we're at 240 volts, 230 supposedly harmonised, but yeah, 240 in reality, and it's not recommended to come in contact with that. It seems to just push it into it. There's not really anything massively holding this in laterally, other than the fact that it's it can't really rotate because it seems to have a shape to it to stop that. But the only other thing holding on is the connections, soldered connections for the heating element. So yeah, there you go. It's got, I don't know, actually, has it even got a keyway in there? Yeah, I'm just not convinced at all with the way this has been put together. No, you see, it can move. It's not the end of the world, but right, and that's the board. It's like a little op amp up here. That's probably reading the signal, if you like, the resistance of the temperature sensor, and doing the conversion and sending it back to the brains of the operation. And mean, it's quite neat. It's all packaged in there, but it's just probably not a good idea to try and package it all into the body of the soldering iron itself. Which is, but quite why that resistor's gone, I don't know. It looks like you've got a fairly, well, the main's coming in here, you've got a fuse here. I've checked that, it's fine. A bit of filtering, and then bridge rectifier, and straight after that bridge rectifier it goes into one side of that resistor, which is gone. So I don't know whether this is cascade failure, and you know that the resistor burnt out because something else went wrong further down the chain. It's annoying that I can't find a schematic to just even temporarily replace it with another one, but I might give it a go anyway. Just it's, you know, it's tricky. You'd have to desolder all these connections here for the LCD, remove that. You can probably just about then fold that backlight out the way to then desolder that resistor and replace it. Yeah, it's not really repairable. Yeah, no, we've got a date on that. So yeah, 2015. Yeah, it's not had that many hours use. I would guess I'd maybe used it for somewhere between 50 and 100 hours. And years ago I used to be a tech in a lab, and it wasn't unusual to come in the morning, switch the soldering iron on, or this one, but more like an old-fashioned just one standard single temperature thing, you know, and just leave it on all day and switch it off before you went home. And don't remember ever having an issue with that. So yeah, right, I managed to, well, easier than trying to desolder all those. I managed just to bend that up out of the way. Obviously, as you can see, I'm probably not intending to actually really fix this. And you get a bit of a better view of the resistor that's died. And yeah, you can see the burn mark on the back of what is a interesting little backlight actually. It's just an LED with some sort of diffusion thing on it, so that's quite neat. I'll take that and keep that if nothing else. Yeah, it's sort of stuck here without being able to tell what that resistor should be. You kind of haven't really got much hope of seeing whether that's the only problem with it. But yeah, I'll just solder something across it. I don't know what. Let's go for a 1K resistor, right? You know, and see what happens. Okay, well the plot thickens a little bit here. I can get a bit of a clue. One of these is really useful for reading the stuff on electronics, tiny little components. So always handy to have. After the rectification of what is mains voltage through the little bridge rectifier here, it goes. There's no well, unless that capacitance. It's difficult to tell with double-sided boards what goes where, but no, it could be actually. Maybe that is the reservoir cap. Although I would have thought that's for the other side. I digress. Rectified mains, I don't know whether it's smooth with the capacitor yet. I don't see any obvious. Goes straight through that resistor and then onto the input pin of this, what turns out to be a little voltage regulator. I've just looked it up, and it gives a maximum input voltage of 30 volts, and it seems to have a fixed output voltage of 3 volts, which would make sense to run the logic for the temperature control, the display, and so on. So it seems they're using that resistor to drop the rest of the voltage down from what would be, well, if it's rectified, 240 volts, but it'd be higher than that because typically the peaks are, you know, that's RMS, so divide by 0.7, you're up around 300 volts somewhere. They're dropping that voltage across a resistor. It's just a bad way to, that's not really a good way to design power supply. They should have just come up with a little, even a simple little switch mode thing to get down to the 3 volts to run the logic. But the idea of just rectifying the mains, then dropping, using a resistor as almost like a voltage divider type thing, just to drop the voltage down onto then the input of a regulator which can only take 30 volts input. It's just kind of, no, I don't I can see what's gone on. Also, if I put a 1k resistor there, it's just going to blow the hell out of the, which this seems to, when I did a diode check on it, it seems to not be all short or anything like that. So I think it's probably that resistor, if anything, just needed to be physically a bit bigger because of the amount of power it's dissipating. Yeah, I think it's just bad design. I don't know what else to say about it. But yeah, I don't think there's really any further I can go with this.